My name is John Brock. I'm a product manager here at Salesforce, and I have the pleasure of joining Ian and Sam. And it's going to be an interesting session today, and you have the pleasure of attending. I am going to act kind of in the role of a college professor, if you will. I'm going to give you a little bit of the theory or the background, the introduction to platform events and our event offerings, and then Sam is really the TA, if you will. He is going to give you some real live examples and maybe go through some lab work with you. And then Ian is our, the person who's actually done this stuff, that actually knows where the pain points are, the things to look out for. And so he's going to be the actual real world experience part of this, this lesson. Hopefully it's not a lesson, hopefully it's more interactive and fun and informative, but also hopefully it gets you excited about our event-driven offerings here at Salesforce. If anyone hasn't seen the slide this week, I will give you $5 right now. No one's, oh, we're going to take a picture of it, good. So basically, we're not going to make too many forward-looking statements in this presentation, but just remember if we do, please only purchase based off of what's available today. So myself, I'm a product manager. Sam is a master technical architect here at Salesforce, and Ian is a software engineering lead at OpenTable, who leads the Salesforce implementation and has direct experience implementing not only event-driven architectures using platform events and change data capture in our streaming APIs, but also implementing event-driven architectures based on Kafka and in their microservice environment that they built at OpenTable. So if you kind of rewind the tape a little bit, right? When we looked at platform events and our event-driven offerings at Salesforce a couple of years ago, we really saw this divide between our experience as a customer, right? Using our great B2C apps, right? Our Ubers, our Macy's app, our Home Depot app, and the experience that we had as an employee, even as an employee at Salesforce, which is a great technology company. The difference is when we have the customer experience, all of our data is connected, right? And we have a very seamless experience using that app. That app knows about me. It's pulling in data from all different sources. I have my Facebook data. I've got my social data. It's got data from purchases. All of that's in one experience, and it's very connected. If you compare and contrast that, how many of you, maybe single sign-on works for some of your apps, and some of the apps it doesn't, right? Like, it's hard even like at an employee experience level to even just have a unified sign-on experience, much less an integrated experience with all the applications sharing data and effectively integrated together. And so we really wanted to provide you, the developers, you, the IT innovators, this event-driven technology built on Salesforce so that you can make these connected experiences not only for your employees, your business users, but also for impacting your downstream customers that you serve and that you sell products to. So if you think about the Uber example, right? It's a very ubiquitous experience now, I would say, right? You don't really think about what happens when you open up that app, but if you think about it, what's really happening, it's pretty magical, right? When I first open up that app, there's a lot of different things happening in parallel behind the scenes to make sure that I can take a ride. We're doing fraud detection. We're doing a credit check against my credit card to make sure it's valid. We're doing geolocation analysis to calculate where exactly I am in the city. And then when I request a ride, I publish an event, right? The event is published from Uber's app to Uber's event bus, and that represents a ride being requested. John's requesting a ride from point A to point B. Imagine if I was creating point-to-point API integrations, and I had to make an API call from my Uber client to every white Prius within 2 blocks of the Moscone Center, right? Even just to the white Priuses, that wouldn't scale or be effective, right? But instead, we publish the event. All the Prius drivers receive that event on their driver app in real time, where it says, John has requested a ride. Do you accept this ride or do you not? When someone accepts, that publishes another event to the event bus that represents a ride being accepted. That's received by me, the client requesting the ride, but also all the other drivers around so that they know that ride is no longer up for grabs, right? Very decoupled integrations, because what if someone's driving in or out of that area? You don't know that you need to make an API call to them, right? You can't dynamically figure out what API calls have to happen. You just need to publish an event. If there's a subscriber on the other side that wants to listen to it, they listen to it and they receive it. Very similar model to platform events. But we know this is hard, right? All these integrations are difficult. They take time, they take all of you, they take complexity, they cost a lot of money, right? You have multiple orgs, you have credentials, you have proprietary data lakes, you've got cloud service providers at Salesforce, at Google Cloud, at Azure, you have on-prem systems. Integrating all those is not easy, right? And we fully understand that. And it gets even worse when you start talking about building and integrating systems, right, at the enterprise level with API-driven models where they're very highly coupled. It doesn't start off so bad, right? I fully understand how Salesforce interacts with SAP and Heroku here, right? My API contracts are well-defined, they're well understood. But what happens when I start adding a few more systems, right? And my IT department starts getting a little bit bigger, right? And maybe there's a few different teams, right? And maybe my documentation isn't quite the best about the exact requirements around the API structures or the request response contracts between these APIs. And maybe there's room for my test harnesses to be improved just a smidge, right? Maybe they're not as ideal as they possibly could. But unfortunately, it gets even worse, right? For a lot of our enterprise companies where you have all these different applications that need to talk to each other, and they do today, but they do in a way that's a intertangled, coupled manner from all the different systems to each other. This leads to basically innovation stifling. Because now when you try to change an app, you try to remove an application, you don't know what's going to be impacted downstream. And the impact may come a day later, 4 days later, a week later. You don't know because all these systems have different cadences, they do different things, there's different SLAs, different requirements. And so innovation really becomes difficult when you're worried about impacting other systems. But how do we move from that model that's very highly coupled to an event-driven approach where all the producers and subscribers of events are decoupled and they're independent, right? We want Salesforce to publish an event to the event bus and then have these other systems in our architecture take action on them as they need, if they need to, right? If they don't care about an event, they don't have to listen for it. But I don't have to change my producer code to remove that API call directly to that application if it no longer becomes applicable, right? I would never remove Oracle from my enterprise architecture, right? Hands down, never remove it. But in the case that someone got a crazy idea to do that, if I removed it from the event bus, the decoupled model, all the other existing applications continue to work. There's no coupling between that Oracle system and the other systems. What if I tried to do that on the left? There's probably going to be some impacts that I don't well understand. And even if I do understand them, I'm now having to refactor both sides. I'm having to refactor the producer side and the consumer side. But furthermore, when I make those refactors, I have to make them in lockstep, right? Because these changes have to go together. Because if I change one, then the other is going to be broken for some amount of time before I can send a patch out. So that's why we introduced platform events. We GA'd high-volume platform events earlier this year, and platform events are native first-class Salesforce objects. They are defined just like you do a custom object using the setup UI or the metadata API. And because they're first-class objects, the advantage of this is you get to use all the platform capabilities that you know and love to interact with this highly scalable distributed system running the event log with tools that you already know and love. You can publish from Apex or declarative process tools or our off-platform or data APIs. You can subscribe using Apex triggers or process builders and flows, or even our off-core real-time Comet D streaming library so that you can receive these events in other systems. An example here is an order being closed, right? We publish a custom signal, and that's what a platform event should represent, is a custom business signal that's specific to your business and specific to your use case. In this case, we close a deal. We need to update inventory on AWS. We need to trigger an SMS from Heroku. We're updating an invoice on Oracle and updating some quarterly reports on SAP. This is all great, but these actions aren't dependent on each other, so they should be decoupled. They shouldn't be related to the other actions. Additionally, we have Salesforce, a subscriber of this event as well. And so these signals were great, but the feedback we received was that yes, right? I love platform events. I understand, I get that I want to send business signals using them, but I need to send signals about when data changes in my Salesforce records, right? That can be done with platform events, but it requires you writing some logic and some code, maintaining Apex, maintaining process builders or flows. And we wanted to do it better. So we built Change Data Capture, which is built on top of platform events. And Change Data Capture is the best way to detect and notify you of all changes happening to your Salesforce data. At the lowest layer of our database in save logic, we detect all DML operations happening no matter the source of those operations, API, UI, Lightning, Classic, it doesn't matter. We detect all of those changes and publish a platform event that represents that change itself. We send you the field that changed and the new value of that field so that you can keep other systems up to date and you can orchestrate different business processes, maybe order fulfillment, based off of that deal being closed. And then it's based on high volume platform events, so we can scale to millions of events per day, and you can replay those events for up to 72 hours. Change data capture at a very high level is very simple, right, for you to think about and kind of visualize. It's 3 steps, right? We capture the change, we publish the change notification, then that change notification is delivered to any subscriber that's interested, right? Just like we showed with the event bus, you subscribe to these data changes on your external systems, and you can keep those up to date, whether it's keeping your system of record up to date, or again, triggering order fulfillment processes or other business logic in your enterprise system. So with that, that was kind of a very high-level overview of the theory. And so now what I want to do is introduce Sam Attal and have Sam talk about some of the use cases, the architectural patterns, and what customers are using events for on a daily basis, because he works in the field every single day with our customers and really knows what the best practices are and how you should be thinking about platform events.
Thank you. Good morning, everyone, or probably good afternoon, right? At Dreamforce, you forget it's a day or afternoon, right? So, first of all, thank you for showing up on the last day, but not the very least days of Dreamforce, right? I'm Sam Attal, Master Technical Architect at Salesforce, and for the next 7 or 8 minutes or so, I'm going to talk about how you can extend and build platform event-driven architectures, as well as some of the use cases.
Sam, I think your microphone might not be working, so let's see if we can.
Okay, I thought I'm that loud.
It's a lively room.
Do you want to use this one?
Yeah, you're going to use your pack, and I'll get you to that soon to get this going. My apologies.
All right.
Oh, much better.
Thank you for bearing for that technical glitch. Okay.
That never happens in software.
Yes. Well, that brings me, again, thank you to John for demystifying Dreamforce bus, which as much as I would like it to be, not an event bus, pun intended. So now we have demystified event bus to a certain extent. Let's demystify some of the different event types that we have at Salesforce. And sometimes they are conflated because of the naming convention or because of their capabilities. So the first in the list is event monitoring, which is part of the Salesforce's Shield suite, and it gives you over 40 different events to monitor Salesforce for security and audit purposes. The second in the list is Streaming API, which was Salesforce's first foray into event-driven architecture and is primarily based on generic and the push events. Platform events, we have been talking about, is built upon Streaming API, augments its capabilities such that it can be used in process builder, flows, and Apex. Change data capture, as John iterated, it allows you to get real-time Salesforce data changes in a turnkey manner without writing any code. Since we are talking about platform events, I'm going to focus on platform events. So where can you use platform events or events in general, right? The answer is literally your imagination is your limitation. So you can literally take upon any use case that requires process automation with event-driven architecture. For example, it can be a simple use case to trigger an order status notification to the customer, or it can be a creative customer loyalty use case to give responsive and dynamic offers across different channels like mobile, POS, or even kiosk, right? In essence, the key message that we are trying to give here is event-driven architecture empowers you in today's connected world where everything is getting connected more than ever to get the right message or right information to the right person at the right time. Now we have noticed events are powerful on its own, but the correlation of events further opens up the door to infinite possibilities. And one of the ways you can achieve today, where everything is getting connected, is through IoT and platform events, which is Internet of Things and platform events. So in the picture on the left, you have a stream of messages that are coming as events, which you can augment with the contextual data that may be sitting in Salesforce, like your device data, if you are using a connected device, or it can be a system, or it can be an object data, which you can then orchestrate using your specific custom business rules to ultimately produce an actionable output. Again, one of our customers, which is a large manufacturer of supercomputers, uses this kind of an architecture to do proactive customer service. As we know, supercomputers are expensive, right? So before even the computer falters, they use this stream of messages to detect the potential error, create a case in Service Cloud, fix the problem, and then close the case, and trigger a notification to their customer saying, we found a problem with your computer, but we have already fixed it, and you don't have to worry about it. Have a good day. Pretty cool, right? Change data capture, again, from the family of the platform events, allows you to, again, use Salesforce data changes in creative ways. One of the use cases is data replication, which is if you are using master data management, you have a lot of source of truth, and you want to create that golden record, you can use change data capture from Salesforce lens. Another use case is process automation, which is pretty prevalent, right? You have some back office integration. So you want to automate that, and change data capture from Salesforce can help you with that. And even for data archival needs. So if you have audit and compliance use cases, and you need to archive Salesforce data, again, in a declarative and turnkey manner, you can use change data capture. Now, I want to wrap up my part by talking about how you can extend the native platform event capability for your complex architectures. So the first probable architecture is using a middleware tool like MuleSoft in this case, wherein you can use out-of-the-gate connectors for platform events and change data capture, and then do some data transformations, or even any kind of data manipulation like data massaging or whatnot. And then maybe you can marshal the call to multiple systems, both on-prem and cloud, in a secure manner. The second probable architecture is a plug-and-play architecture, where you can extend Salesforce's event bus with another highly scalable distributed messaging bus like Kafka, where you, as a customer, you can use your own managed instance of Kafka, or you can use a fully managed Kafka instance on Heroku Kafka as a service to ultimately wire up your product apps, perform external computation, or even support your microservice-driven architecture. These all architectures are great on picture, I know, and in theory, right? So you must be wondering, this is all slick and maybe cool, right, to look at them? But tell me more when the rubber hits the road, right? We hear you. So to talk about how these architectures come to fruition in real life and what it takes to take them to production, please give a hand and welcome Ian from OpenTable.
Thank you. Thank you so much, Sam. If our clock is right, we have actually a couple more minutes of morning, so it is a good morning. Okay. So yeah, John and Sam gave you a really good high-level overview of platform events and event-driven architecture. I'm here to really make the conversation just a bit more real-world. I want to do that by talking about some of our use cases, showing some of our system diagrams, and even talking about some best practices that we followed that I'm hoping will help you as well. Before I do that, I'd like to talk about the journey that OpenTable went through some of the system architectures they've had over the years. Like many other tech companies, we started with this very kind of monolithic architecture. It was a series of large systems with little or no integration. And sometimes users would have to do that swivel chair thing where they'd context switch and look at different systems and enter data manually into those systems. But then the waves of service-oriented architecture kind of moved over the industry, and we followed that. We started to break systems up and connect them through API. This was actually a good progression, but as John and Sam were talking about, the tight coupling started to give us some problems. We also had a lot of ETL jobs moving data between systems at this time. Now, today, I think we're in a place that John and Sam may call the promised land. So all of our systems are broken up into microservices and microsites, and the communication between those services is through messaging. I'd like to show you some of the system diagrams that better illustrates this journey. So I'm going to fast forward past the monolithic time, because that was about 10 years ago. This is about our 3 to 5 year ago mark, where we're connected through ETLs and APIs. The very first thing you'll notice here is the lines are really going every which way. I didn't add any arrows to these lines because, to be honest, the data was just flowing in all different directions. A big problem with this system was there's no consistency to the integration patterns. Some of the data was being moved through batch jobs, some was through database query, some was through stored procedures in a database, some connected directly through API, some through custom API. It was all getting really hard to keep track of. And another issue that we had is this wasn't real time. So a lot of times users would just have to kind of sit around and wait for updates to downstream systems. The moral of the story here is that these different integrations were getting really hard to manage, and they weren't making our business as efficient as it could be. Just one specific example to illustrate how this kind of took a drag on our business. If we wanted to add one field to sync from the Salesforce to these internal databases, it actually took 5 code changes that happened to be in 5 different languages, and it took 5 different production deployments. So it was pretty obvious that we needed something way better. But before I talk about the new architecture we have, I'd like to share with you just a couple of the use cases that we use to justify the move to an event-based solution. So firstly, we needed to sync our account and contract data in real time to our internal financial systems for billing and invoice generation. For a long time, we got away with doing this in a less real-time way, but we decided it was a priority to be able to show our customers their billing information on demand, and not just once a month. Next, we needed to send important signals. These are the signals that John was talking about to other internal systems when major events happened in Salesforce. These events are key moments in the overall life cycle of accounts or products, such as activation or termination. So now that you know some of the use cases that we use to justify this model, let's take a look at our new world. So right off the bat, this is way cleaner. There's one entry point to every box, and there's one exit point to every box. There's a warm consistency to the pattern. I'd like to give you a walkthrough, because this is the important diagram of the two. Starting from the far left there, we're publishing our events from Salesforce, and you can follow the line that kind of goes up and over. And it publishes the events to the box on there called service number 1. We publish these events in really all the event-based technologies that Salesforce offers. So we initially started with the streaming API. We use platform events, and more recently, we're starting to use change data capture. Service number 1 is a Java-based microservice. Actually, all these little boxes here are Java-based microservices. But this specific one uses comment D to subscribe to events. So this is how we get the events into the OpenTable network. So service number 1 does something interesting. It then republishes that event to the long middle box called the event service bus. This is something custom that we built at OpenTable. The whole company uses it to facilitate message-based communications between systems and services. Like many others who built a custom bus here, we built it on top of Apache Kafka. And it was built in a way that other teams can subscribe or put events on the bus using any language they wanted, so Java, C# or Node. One of the other services here that pulls events off the bus is actually service number 2 on the far right there. This is a service that we built on our team, and it actually receives the events and then calls back into Salesforce through API. It goes through this service up here called the proxy service. We do some really cool stuff with this, actually with the composite API. So if you haven't took a look at that, that's actually really cool. And lastly, the small boxes on the bottom are just representing services by other teams. So let's go over some of the advantages that we gained with this new architecture. Very firstly, teams no longer block each other as much as they used to. This is because of loose coupling. They can be developed and deployed independently, all these services. Teams can now swap out and refactor services, much like John was talking about, because of this loose coupling. And then we found that this actually helps with our technical debt problem quite a bit, because we're not blocking each other from swapping things out. All these communications are finally real time. So we don't have to sit around and wait for updates, and we don't kind of monitor all those batch jobs. And of course, we love the consistency of the pattern. Just makes things very clean and easy to work with. Just to follow up on that one painful example I talked about that took 5 changes, 5 different code bases. With this new model, we actually just make 2 configuration changes. One on the Salesforce side to add the field, and then one configuration change to a YAML file on the subscriber. So basically no deployments. So we're really seeing a return on investment on that front. So here we are today. This is a few-year journey. We definitely hit some bumps along the way, but the good news is I'm here to share with you the ones that tripped us up the most. So hopefully your journey is a little smoother. I have 5 to share, so let's go. First up, you want to know the limits that you're working with messaging on the platform. When you start to look at the limits, you're going to want to look at what John mentioned, which is high volume platform events. These are used by platform events, but also change data capture. There's an API that's available called the Limits API. This is the API you're going to need to use to check your limits. And it could be different depending on the version of Salesforce you have. So you really just want to use this API to define the source of truth for those numbers. The parameter that you want to check in that API is called monthly platform events, which I show here in a screenshot. In my specific org, I had 1.5 million platform events per month. But there is a bit of a secret. The system actually holds you to a daily limit. You can get that daily limit by doing some pretty simple math. You just take that monthly limit and you divide by 30, which takes my limit down to 50,000 events per day. It makes the limit sound a little bit tighter. So when we actually hit the limit, we started tracking the events much more closely. And with normal user activity, we found that we're safely under the limits, but there was a couple use cases that we found that very quickly takes us to that limit. The first use case is when admins or other users are doing mass updates through data loader. So that'll fire off a bunch of events in the system, and that took us to the limit. Secondly, if the subscribing service goes offline, say it's down for 2 days, and then it wakes back up and starts subscribing back where it crashed, the catch-up activity of getting all those events for those last 2 days would take us to the limit. As a final note, there's a workaround to the limits, which we actually just did at OpenTable. There's an add-on for purchase that effectively just removes the limits. So if cost is not an issue, I'd recommend doing that and saving yourself some headaches. The next lesson I'd like to talk about is the retention period. You want to know this on the system. So if you're using the streaming API, which you shouldn't be at this point, you should be using platform events or change data capture. The retention period for the streaming API is 24 hours, and the retention period for events on platform events and change data capture is 72 hours. So I bet you're wondering why this number matters so much. Well, basically, if your system stops subscribing to events, if you don't, say it crashes for some reason, if you don't get it back up within this retention period, you could risk losing data, actually. So you want to get it up before that window closes. Next up, let's talk about the EMP-Connector. If you haven't heard about this is actually a Java-based implementation that uses Comet D. It's often referenced in the Salesforce documentation as a way to get up and running on platform events very quickly, and it truly is. I had an engineer do a proof of concept when we moved from the streaming API to change data capture, and he was able to spin something up in literally a few hours. So it's actually great for that. The problem is this particular connector is not owned or supported by Salesforce. So if you run into issues with it like we did, you're kind of on your own. The good news of this story is that there's plenty of other options to subscribe to his events outside of this connector. You can build your own connector. You can use one of the other connectors in a different language. But I think what I would recommend is maybe if it's an option, use Heroku or MuleSoft, because I know those two options actually are very supported and owned by Salesforce. So these top three were the most impactful to us because they cause production outages. The next two I have are actually more along the lines of best practices. This one here is about how to find errors in your system. Very shortly after you get your system up and running, a subscribing team to your event is going to say, hey, we're expecting this event. Did you send it? And you need to be able to answer very confidently whether you did send that event or if there was an error sending that event. The tricky part here is the Salesforce doesn't really give you a way to check all the events that was fired from the system. So as a recommendation, I would say adding a database to your subscribing service really will help with this event tracking. specifically with the error tracking. We did this by connecting a small Postgres database to our subscriber. Along with the database, I would recommend setting up some alerting and monitoring for your services, mostly for the errors. But this monitoring can also be used to track activity in the system. So big spikes in activity, or lulls or flat lines in activity. You may need to do a little bit of calibrating with the activity tracking, because there's going to be some natural dips in activity, say like on the weekends or at night. But specifically with this error alerting, giving a callback to lesson number 2, if you get alerted when these errors happen, this is going to allow you to get your system back up and running within that retention period, so you don't lose any data. Lastly, I'd close with a few best practices that we have found with event-driven systems. Firstly, there's this domain problem. So once you start breaking things up into smaller services, you want to define clear domain boundaries between the services. And if there's something very specific or even confusing about your implementation or your particular domain, you don't want to pass those complexities on to your subscribers through your message. Try to abstract away those details and speak in very commonly understood language. Kind of related to domain boundaries, you also want to make sure that you're the source of truth for that information. You don't want to just relay data. Next listed here, you don't want to be overly chatty with your events. Make your events very specific and mean something, unless you're doing a full data replication. And third listed here, you want to come up with a versioning strategy for your events. This is something that we're doing now at OpenTable. This is very analogous to an API versioning strategy where the consumers can just update to the new version at their own pace. And finally, one very last lesson, if the movie Speed taught us anything, you never want your event bus to process events slower than 50 messages per hour, or I'll have to send Keanu to come rescue you. So this is actually the conclusion of all our content today, maybe the last session you have this Dreamforce. Thank you so much for joining us. Speaking for the group, we really loved giving you this information. I think we hit pretty much the time mark, but we'll stand off to the side here if there's any questions for us. Thank you.